have to say
So, guys, we are ready.
That's right.
Okay, do you want to say hello?
Hi, what is your name?
Hello.
What's your name?
Veronica.
Veronica. Yeah. Who do you want to say hello to everyone in? Bangladesh. Hi. Thank you.
Hello, Veronica.
She says hello.
Okay, thank you. So, guys, we can start now. We're already live. Let's start our virtual Jack session. So, welcome everyone. We're live from Java User Group Bangladesh. We have two special guests today from Ireland. I think you are now living in Dublin, right?
Yes.
Okay. Thank you thank you coming and having some time with us. So let me introduce first with our guest. We have two guests. One is Rafael, who is working on NoBugsProject. Am I right, Rafael? How are you, man?
Yes.
So
I'm fine. Thanks.
He's a system analyst and he works for NoBugs, No Stress, a life-changing software without destroying life project. So mostly he will help you to relieve your stress from your coding career. And we have also Barry Evans, who is a senior application consultant, Dublin JUG. Thank you guys for the time you are going to stay with us. So let's start with the saying hello to everyone.
Yeah. Do you want to start, Rafael?
Yeah, Rafael, say hello to us,
So,
to our audience.
Hello, everyone, and I'm honored to be here at the Bangladesh JUG. And I would like to thank Basler for this opportunity. I'm happy for this to be presenting here at the JUG.
Okay, thank you, Rafael, for your time. And obviously, we have Evans.
Yeah, hello, folks. Hi, my name is Barry. So yeah, I'm a senior applications consultant at a company called Version 1 based in Dublin. And yeah, it's great to be here. Thanks for giving us the opportunity to present the Java challenges to you. I hope you find it interesting.
Obviously, and I'm sure I'll be enjoying, and I'm sure our audience will be enjoying as well. So let's start with the presentation.
Okay. So I'll maybe start off quickly here. If I can just point everyone's attention to the website Slido. And we're going to make this an interactive session where you can go to the Slido website, type in the code 7834, and then you'll be able to participate and answer the questions every time for each challenge. And so, sure. Rafael, maybe you want to present them what the purpose of the presentation is. Hand over to you.
Yes. So at this presentation, we will be learning the concepts behind 10 Java challenge in order to eliminate stressful bugs. Because if we learn the main concepts from the Java core, we can avoid really, really annoying bugs. So here.
Okay, perfect.
Okay, so here is just a brief presentation about us. As Basler told us, I'm the creator of NoBugsProject, and I have the NoBugs No Stress book, and I'm here to share with you content to avoid bugs and stress. What about you, Barry?
Yes, so as I said, I'm from Northern Ireland, and I've been a Java developer since about 2007. I'm a big fan of clean code and test-driven development, and I really just like bugs and untested code. That's why a passion that myself and Rafael share. We want to get rid of bugs as much as possible. Recently, I got the OCP certification for Java 8 Standard Edition. And as I said, I work for a company software consultancy called Version 1. This is the first time I've interacted with the Bangladesh JUG. Very honored to do so. And I also am a member of the Dublin Java user group. So yeah, we want to try and get Java user groups talking to each other across the world. So this is a great opportunity.
Yeah.
Yeah.
So the topics we'll be covering is generics, strings, trace syntax, method overloading, threads, equals and hash code, sorting and comparable, strings, and polymorphism. So, okay.
All right, go ahead.
This is the, can you share the challenge? I think it's not appearing here.
Okay, I can see it now on my screen.
Okay, now I can see it.
Okay.
Okay, now I can see it. So this is the first challenge. It's about generics. Basically, in the first statement here, we are instantiating the factory class, and we are passing Simpson instance. And we are passing the Simpsons instance in the generic type. So you can see that in the factory class, we have the generic type T, and we are receiving any class into the constructor, in the factory constructor. Okay? So at this moment, we have Simpson inside the factory class. And in the second statement, we are using the method add to list, and we are passing one array list and also another instance of the object of the class Simpson. And so inside this method, we are adding the types inside the list. And on the bottom, it's just a podio, simple podio. So there's nothing else here to describe. So let's see the alternatives. So you have 4 options here. So what do you think? Do you think it's A? It will not compile. Do you think it's Homer and Bart? Do you think there will be a runtime exception? Homer. Sure.
I think we may have lost you there a little bit, Rafael, at the end there.
Okay, so guys, you have a challenge here, and in this slide, you will be able to see a poll. There will be 3 answers. So
yeah, I can show the poll. So this is the poll at slido.com. So if anyone is taking part, if they want to have a look at the Slido website, and then they can give their answer. And then we'll have a look to see what the answers are at the end.
Okay. Let us know if you have any problem with the slides. Comment on the YouTube chat sections so that we'll able to help you out.
Sure.
I'm not sure if people can actually be able to join.
Do we know how many people are connected?
We have currently, yeah, sure, we can see that we have more than 13 people here.
Okay. So maybe give people a little chance to answer.
Yeah, for the first one, I think we need to give some time. Guys, so let me talk to them in Bangla if they understood.
Yeah, I'm watching the chat now.
Yeah, okay. So I don't see anything in the chat.
So okay, I just noticed Motolib has said, Motolib Mia said the video is not clear. Hopefully it gets a little bit better.
Okay, see guys, you have three options here. Okay, one said they didn't able to select answers. I see.
Okay.
Yeah, the answer is not selectable. I can see that as well.
There's possibly a small problem here with it. Usually this works seamlessly. I just need to make sure the poll is activated, but it should be. This is kind of like a live coding demo. You know, there's a disclaimer, things may or may not work.
Okay, so let's go on the presentation, and let's show the answer.
Hold on a second. The link's incorrect. If you want to wait 1 second, Rafael.
Sorry.
If you want to wait 1 second, I can send the correct link.
Okay.
Actually, I don't seem to be able to send it. I'll send it to you in the Google Hangouts.
Okay, yeah, that will work.
Yeah, because actually YouTube didn't allow me to paste it, so that's the link there. You have to type /polls to get to the poll.
Okay.
We'll get there.
Yeah, live thing is always problematic. It may work or may not work. So guys, there is a new link in the chat box, live chat box. You will be able to select that. Go to the link and you will be able to select the options.
Yeah, once we get the first one working, then we should be good.
Then we'll, yeah. I'm not sure it's working. It's working. No, it's not working as well. Did I copy? Oh, see, we have already one vote there. So it's working for some people, not for everyone.
So if you just go to the if you just go to sli.do and type in the code 7834, it should take you to the poll.
Okay, so yeah, the code is 7834. So I can open it. I can see it.
Okay. Yeah, I think the link that you've pasted into YouTube doesn't seem to be working.
Okay, let me try again. Sorry guys for the delay. It happens. The live events always, you never know.
Yeah, no problem. We'll get there.
Yeah.
So I think actually if you just go to the slide https://sli.do, and then it will ask you to enter in the code, because the links you're sending there, I don't think they work.
Okay, yeah, that's problematic. I see these links somehow get broken.
Yeah.
So
we do have one answer so far.
Yep. So it worked for one, but not for everyone actually. Can you show it in the screens how to do that? I mean, people will be able to.
Yeah, I can. That's not a bad idea. So I'll just go to sli.do.
Yeah, you have to share your screen as well.
Okay. Can you see my screen?
Yeah. Yes. Now we can.
It's still showing the slides. What can you guys see on my screen share? Is it the PowerPoint slide or is it the poll?
I can see a poll.
Okay. What about you, Rafael?
So let's try again. If it works, otherwise we have to go ahead. I mean, we're
okay. Okay, maybe we'll just go with the showing the answer then, will we?
Yeah, let's do the first one and we'll go ahead. Otherwise, if it doesn't work, we'll share the concept.
Sure. Okay, Rafael, should I show the answer?
Okay, so show the answer.
Answer is D.
Yeah, so the answer is Bart and Homer. Can I see the challenge?
The concepts?
So basically, we are exploring here the generic type parameters. The challenge again. Can you mute? Yeah. Because I think it's not appearing the challenge for the audience.
Okay, there we go now.
Yeah, now it's appearing. Okay. So basically, created the factory class, and we passed an array list and the Simpson object, and you can realize that there are important concepts here. You can realize that there is a generic inside the method. The generic inside the method is shadowing the T type inside the factory class. So there is a T variable, a T instance variable inside the factory class, and in the add to list method there is another T. You can realize that it's adding first the Bart object, and the second statement we are adding the T from the instance variable. That's Homer, because we passed in the first line. So it's in the list, it's returning basically Bart and Homer. So print those two names. So we've got to know, we've got to avoid this kind of shadowing. You see that if we referee type inside the method, the preference is always the T from the method, from the parameter. So from this, can go on.
Okay.
Yeah, so we saw here generic type parameters scope, and shadowing. Okay, so this is the second challenge. We are going to explore the strings right now. So in the first statement, we are seeing a comparison of two strings. The first one is powerful code, and we are using string, and we are comparing. We are asking if they are equals with the sign equals equals. Okay. The second statement, we are comparing if the string flexible code is equal to flexible code. In the third statement, we are forcing instantiation from do your best, and we are comparing. We are checking if they are the same. And in the third statement, we are comparing if NoBugsProject string is equal to the second project. And right now we want to see the result. So we are comparing here. So the letter A is 2, 3, 6, 7, and so forth. And we'll give you some time to think about, and we're going to answer.
I think it's really quite some time to process.
Yeah, take your time. Take your time.
Okay. Take our time. Take our time.
By the way, we had 3 responses for the first question, and everybody answered correctly. So well done.
Wow,
that's great.
Okay,
that's great.
So
So Basil, I think the challenge is not appearing to the audience.
Oh, really?
Yes. Let's share for let's.
They can see the.
It's still not appearing.
I can see the challenge. I can.
Yeah,
I can see.
I can see the answers as well.
Yeah, I have opened another screen for YouTube Live, and I can see there it's.
But are you sure that it's appearing for the audience? Ask the audience.
Yeah, sure. So guys, if you don't able to see the screen of the challenge, let us know in the comment section.
Yeah, because I'm seeing your screen now.
Which screen?
Now it's okay, but the audience is not seeing the code, so it will be difficult for them to answer.
Okay, well, there's two answers so far. Three answers.
Are they seeing the code?
They must be able to, yeah.
Now it's appearing. Yeah, now it's okay.
Okay, maybe I just switched the view there. Maybe it's a bit of lag. Okay, so we have 3 answers. Should we go?
Okay, I think we can go ahead now.
Okay, I'll just show the poll what the results were. We have 4 answers now. Can you guys see the poll?
Yeah, we can see the poll.
Okay, good. So now 5 answers.
So just change to the code, Barry, please.
Sure. Okay, so it's 5 answers, C and D. The answer is?
It's A.
So which one is correct?
Yeah, this one is tricky.
Yeah,
because when we use the string method, it will be just equals the other string, but using string method, it will create another string, the heap. So there will be 2 different objects. So the concept here is that when we use the equals signal, we are comparing objects instead of the value. So we are seeing here in string pool, immutable strings, and we are in the second statement, we are comparing if the strings are equals. If they are the same object, so it will be 3. Okay, and in the third statement, no, do your best is the same as do your best. In this case, they are the same, but they are different objects. That's because when we are using the word new, we are forcing the pool. So we are forcing to create another string, other object memory. So there will be here two objects, two different objects. So that's why it's false. It will be 6. And the fourth one, we are comparing a new string with the method equals. And as you know, the equals method compares the value and not the object. So in this case, it will be true. It will be 7. And that's why the result is 2, 3, 6, and 7.
Perfect.
Yeah, so there was no correct answers there. That's good. You're learning something.
It was a tricky question, obviously.
Yes, it is. It is very tricky. Okay, so we saw here the concept string pool, immutable strings. It's different to the equals method. Okay, let's go to the other. So this is a really well-written class, and well, you can see that it's not confusing at all. And the name of the class is it going to compile? And we can see here that there are several generics here. So there is the A-type extending objects and DC, D4, D7, underline 0, extend hash map, and WO, W are the money symbol, OP, so it's completely insane. And you can see that there is a casting from a serializable anonymous generic class. And there is the transient reserved words here. And there is a lot of inner classes. We see A again. So, and there is the reserved word volatile and strict FP using generic. And we are instantiating all the inner classes inside the strict FP method. And also we are using the for looping, just showing the string it won't compile a lot of times. So can we see the alternatives? Okay. So the first one, it won't compile at line 12. The second one at line 11. And the third at line 24. And D, it will compile.
Okay, this one will take more than what it took for the first one. It's quite tricky.
Yeah, it is.
Does anyone answer it yet?
No answers yet, no.
It will take us some time, I guess. So there is new, okay. How did you come up with this idea? I don't know.
I was inspired.
Did you write this sort of code anywhere?
No, just for the challenge.
If you were dare to write this sort of code in production, I'm sure you will get fired.
No question about it.
Okay, I have still no no answers yet.
So, guys, those who are watching, you can comment if you have any problem with this, or you can share your ideas. We can discuss about this. I know this syntax is quite crazy, and it's really hard to process on our head. I'm not even sure it will compile.
Yeah, you have 3 options there. Do you think it won't?
So did you get A, B, C, D, E, D4, D7? So we have no answer yet.
We have one answer for A.
Oh.
Somebody's answered A.
Okay, so I think we better let's explain. I mean, this is really a difficult one.
Okay, so let's see the answer.
That's the answer. The answer is
it will compile. So
Oh.
yeah, this is crazy, but it will compile. Yeah. Actually, let's see the main points here.
Okay, sure.
So for looping structure, variable names, and generic type declaration. So let's go to the code. So here we can declare as many generics as we can. So as we want. So in the generics declaration in the class declaration, we can just put as many generics as we want. And about the variable declaration, we can use the money symbol. We can use underline as well. And we can cast a serializable anonymous generic class to the generics OP. And we can put as many semicolons as we want there as well. And we can use the volatile reserved word. And in the for looping, we can use we can use a sysout inside the for looping. I know this is strange, but we can do it. And the strict FP reserved word is something related to a float number to have a really when we have to have precision in the numbers, the strict FP in daily work we will never use it. It's very difficult to use it. And the native reserved word to compile a C or Java application. And that's it.
This is a really good example how not to code.
Yeah, indeed. But I would add to that, it's okay to add code like this as long as you have a unit test. Okay, so the answers
All
there
right.
were...
What about the multiple semicolon here?
Okay, sorry, I was just going to show the poll there. 2 people answered A. Are you still there, Rafael? Okay, I don't know if we still have Rafael anymore.
He's online, but not sure. You can go ahead. We can wait for him.
Yeah, let's see.
Oh, he's not here.
Okay, you had maybe I can fill in. You had a question about the semicolons.
Right. We have a few semicolon in the code as well. So is it also permissible in Java?
It is. Yep, it is, and it's funny because you would think that multiple semicolons wouldn't work, but yeah, definitely that code compiles, which is very strange. But if you eliminate a semicolon, we all know that you'll have problems then.
Oh, Rafael, back. Right.
Oh, sorry for this.
There we go.
Okay, let's go on.
Okay, yeah.
Let's go. Go on about the next.
Okay.
I've just changed the slide. I think it's just updating now.
Okay, so this is the Lambda challenge. So we are basically declaring a variable, a string variable here, and we are using the use revolver method. Basler, I think your screen is appearing. And yes, could you fix the challenge screen, please?
Yeah, it should be showing it now. It should be showing lambdas.
Yeah, now it's appearing.
Yeah, the number is not right, I think. It says 3. I think it should be 4, right?
3. Yeah, I think so, yeah. Sorry about that.
That's all right. We can go ahead.
Okay. Okay, but I think the audience is not seeing. Okay, now it's appearing. Okay. Okay, I'm going to. So in the second statement, we are using the method use shotgun, and we are returning a string, basically. So you can check out that there is the use revolver method and the use shotgun method. And there is the revolver interface. And also there is the shotgun interface with the shoot method and the full method reload. So let's see the alternatives. Okay. So we'll give you some time to think about the answer and then you can respond it.
Okay, finally we have lambdas.
Yes. Basler, try to just to tag the challenge, because I think the audience is not seeing. I don't know if you are understanding what I'm saying.
Yeah, the audience is seeing. I can see that. I have another screen for the audience view. So.
Oh, okay, no problem.
Okay, we have one answer so far.
Let's see. It's also a little crazy. I mean, it's tricky. We are passing lambda expression inside another. So I'm sure those who doesn't know lambda expression might have problem with it, but so Java, it brings with lambda expression, which is we love. I mean, personally, I use a lot of lambda expression in my code. So you can think like anonymous inner class. So you can just replace anonymous inner class with lambda expression with shorter syntax. For now, if you don't understand lambda expression quite, you can just replace the arrow sign with anonymous inner class for now. Am I right?
That's a very good point. Yep. And that's one of the nice things about moving to Java 8, where a lot the code's more concise and you don't need all these anonymous inner classes.
And by the way, Java 10, I'm hoping they are going to do more concise syntax for variables. So they are bringing the var keyword. So I think in that case, we are going to see a lot less code. Like you can just declare var instead of a string or any other things.
Yeah, that's
yes.
The type inference it's called,
Right.
isn't it? Yeah, that'll be nice.
Yes.
So
okay, how many answers do you have, Barry?
We have 3 answers. 2 for C and 1 for D. 2 for C and 1 for D.
Mm-hmm.
And if you let me know if you want to go ahead. I think last time we had 6.
I think we can go ahead because we are still at 4. I mean, we have to go next.
Let's go.
Sure.
Yeah.
Okay, so I'll show the answer now, and it is
C.
Okay, the answer is C. Congratulations. Okay, so the concepts here is about functional interface, default methods, okay, and Lambda syntax. So let's see the code now. So basically here, the trick is about the default method, because we know that Lambdas just work with functional interface. What is a functional interface? It's basically an interface with just one method. For example, the comparator and the runnable interfaces are functional interface because they have just one method. Okay, so in the first statement, we are using the method useRevolver. And in this method, we are passing the revolver interface, and it has just one method. So we are just returning the string. And so it's just going to pass this string, and it's going to print this string. And the second statement, we are using the method useShotgun, and we are returning the string, and it compiles because it's a default method. So the interface can have as many default methods as we want. So, and but it has to have just one public method. If the default method was a public method, if it was a normal method, it wouldn't work. So we can have as many default methods as we want. It will still be a functional interface. So it will work, and the output will be bun, and boom.
So basically, for in interface, we can have one abstract method and as many as default method we can have, right?
Exactly, yeah. So we have to have just one abstract method, and the default methods, never mind. Doesn't matter.
So there is one question I would like to ask. I mean, it may be obvious that we can implement a class with methods, but what's the point of having so many default methods in an interface?
So what's the point of having different interface?
Default
what's the
methods.
point of having different multiple default method?
I could understand
one
your
can
question.
Ask, so the question is,
one
can. Yeah, sure. Go ahead.
So I could answer that. So the reason is you can have, well, you know, interface methods are static. You know, so you can always call them statically. So basically, you can have many default methods. So it would be logic relating to an interface. And there's, I think, in the comparator interface, there's a method called then comparing. Comparing. So that's a good example of where you would have multiple default interfaces in, I think, the comparator interface, which you'll see in the JDK.
So basically, the idea is if we don't want user to implement a certain interface, we can add we can provide a default implementation. User can just use that.
Sorry, I lost you there. I didn't hear that.
So let's say I have an interface with one single abstract method, and I can provide an default method, so user can use that without having to implement this method for those class they have implemented this interface.
Yes, you're not obliged to implement the default methods. Yeah.
Okay, go ahead. Let's
go
ahead.
If you were to look at one interface in the JDK, it would be comparator, because you can see in there the all the default methods and how they have logic in there to do things like to compare certain data types, that kind of thing.
Yes. So let's see the concepts again.
Sure.
Functional interface and default methods and Lambda syntax. Okay, let's go to the other one.
Okay.
So this one is really tough.
Yeah. Okay.
Okay, go on, Basler.
No, it's okay. I was asking to go next. Go to the next.
Okay, so this one is a tough one, and it's about overloading, and we are executing 4 methods here, and we want to know what's the okay. So in the first method, we are passing the number 1, integer number, and in the second method we are passing, it looks like a float number, 1.0. And in the third method, invocation, we are passing the wrapper number double with the 5, with the 5 value. And in the last method, we are passing the number 1 with an L in the end. It looks like it's a long, okay? So, and in the end, we just want to know what is the output from the X variable. Okay.
All right.
So this is advanced overloading. It's not an easy challenge, so we'll give you some time to think about it.
So basically, you have overloaded this method for integer, object, short, float, and double, as well as object.
Exactly.
So you are passing 1, which is definitely a primitive 1, and then 1.0, that's also a primitive 1, and then you are passing an object, and then you are passing in long. I have my answers, but I would definitely love to see what.
Okay. Yeah, we still have no answers yet in the poll. I know this is definitely.
This is definitely a tricky one. I mean, all of the problems are difficult, obviously. Let's wait 1 or 2 minutes for this because it's number 5 and we are almost 10:57, so we don't have enough time.
Yeah.
Yeah, I'll go through my other 5 as quick as I can.
Yeah. Okay.
Okay, we have 1 answer so far. And thanks, guys, everyone in Bangladesh for staying on so late. We really appreciate it. I didn't realize how late it was with yourselves.
What is the time in Bangladesh?
It's now 10. It's almost 11 p.m.
Whoa.
Basically.
Yeah, we have to thank you because I mean it's a Saturday night.
Right.
So thank you very much for being here. You are very dedicated. Congratulations.
Thank you. So meanwhile, I can tell you guys, we are really open to this kind of session and we're welcoming a lot of people from around the globe. So if you have a new session or you have a new idea about you want to speak, we can always have a session like this, and you are most welcome. If you have some ideas about something, we can do it in our group, in our jugs. So in fact, we are hoping to do a physical one in next year, January or February. So if you want to join physically, you are also welcome.
Wow.
And
it's an honor for us.
How many answers do we have now?
We have 4 answers. We have B has got 2 answers and D has got 3. So maybe we want to show.
Okay, let's go ahead because we have to go first now.
Okay, let's see the answer. It's C.
Okay, yeah, nobody answers C. Wow.
Yeah, as I told you, it's a tough one. It's very tough, this one. So one important thing that you have to remember here is that the JVM is lazy. So the JVM will take the less effort as it can. So the concept that we are going to explore here is widening, boxing, and varargs. Okay, let's see the code. So the first thing you have to realize here is that we are passing the number 1. And when we pass the number 1 like this, it can't be short because the number 1 like this is just integer. The JVM understands this number as an integer. So the first letter will be E because it will be widened to float. You can see in the bottom the sequence of widening. So it's byte to short and int to long and float to double. So in this case, the widening concept happened. So the number 1 integer went to the float number, okay? So in the second statement, it's not a float number because when you declare the number like this, it's a double number. So that's why it's going to be F. And it's just a double. There's no widening happening here because this number is double. And in the third statement, we are invoking this method and passing in a wrapper. And the number 5, we are passing inside this wrapper. And as I told you, the widening is better in this case instead of boxing. So as you know, the double class is an object, so it's easier to this method go just to the object. So the third letter will be C, because it's much easier to go inside an object. And in the fourth invocation, it's we are passing a long number, and the long number is going to fit into the float type. So the long number can't be short, and can't be anything else. So it has to be a float. Okay, so again, we are using the widening concept here. And one thing that is important to remember, to keep in mind, is that varargs is the 3 points in the first method. It's always the last one to be invoked. So that's why it wasn't invoked at all. Okay.
All right, I can understand that now. I was wrong, in fact.
Yeah,
okay,
it's definitely the trickiest one for me, anyway. Okay, so we actually had six answers there. You can see.
Mm-hmm. Yeah.
How many of them are correct?
We have 2, I guess.
Okay.
2 people
To
got it
correct? Oh,
well done.
great. That's great, yeah.
I think that's the highest score ever.
Okay, let's go into the next one.
Yeah, okay, so there we go. So you just want to summarize there, Rafael?
Yeah, so here we saw widening concept, boxing, that is basically transforming wrapper to primitive. And this takes more effort to the JVM. That's why the widening concept was used with the double wrapper. And varargs is always the last one to be invoked. So we have to keep this in mind.
Okay, thank you, Rafael. So then this is the second part of the challenge presentation. We're going to talk about threads now, a pretty important concept whenever you're doing multi-threaded programming, if you want to do concurrent programming in Java. So I'll draw your attention to the motorcycle class at the bottom of the slide here. We can see that it's just a class which extends thread. We have a constructor which takes the name of the motorbike and it just passes it to the super class's constructor to set the thread name. We override the run method, which you would do whenever you extend the thread class. And in the run method here, we increment the Wolverine adrenaline counter, and then we check to see if the counter is currently at 14. If it is, the object will then print the name of the thread out to the console. So quite straightforward enough. Then if we go up to the top of the thread challenge, we see we have this static counter called Wolverine adrenaline, initialized to 10. In the main method, we create 3 motorcycles, first, second, and third. And then our last motorcycle is a little bit different. We want to make it the fastest bike. And so in order to get it moving a bit faster, we set its priority to max because we want it to run as quick as possible. We also set it as a daemon thread. Then we start that thread as we do with all the others. And we just want to know what will the output be to the console. So there's your options there. Is it first, third, last, or indeterminate? I'll give you a minute to look at the code. Okay, one answer already. Good.
Yeah, this your the complexity of your problems are getting higher and higher one to another.
So I guess the main thing here is we have normal motorcycles first, second, and third, but then the last motorcycle is a little bit different. It's the main thing to think about here. Okay, with 2 answers now.
Perfect. So we have 4 threads right here, and one of them is daemon, and we have said this last one makes priority. So it's going to take the priority.
Yeah, and yeah, the last thread is a daemon thread, so it's the previous first, second, and third. They wouldn't be daemon threads. Okay, well, 3 answers now, so we'll maybe push on and I'll show you the answer so that we don't keep you guys up till midnight. So the answer is...
Sure, go ahead.
D. The answer is D. Okay, so this is good. The trick here was to the challenge here was to try and trick you a little bit as well. So we're going to look at 3 points here: the thread execution order, how the threads actually get executed, the thread priority property, and then also a little bit about daemon threads and what they are. So if you look at the code here on line 12, you can see that we set the priority and the daemon properties of the final motorbike. Now the thing is, in the JVM, you cannot guarantee the order that threads will execute. Basically, when we call the start method, we just queue up the thread and we ask the JVM to execute it at a time that it finds, you know, convenient. So even though we set the priority of the final thread to the max priority, it's only a preference. It's not actually guaranteed. So that wouldn't allow us the last thread to execute ahead of the others. The second thing is then about the final thing is about the daemon threads. So whenever the JVM starts up, basically there's one non-daemon thread, and that's the main method that everyone would be familiar with if you're debugging. So the only way that the JVM will stop will be whenever there are no non-daemon threads left to execute, or you call the system exit or the runtime exit static method. So in this situation here, we may not get any output at all because the first 3 threads could start, execute, and then the only other thread waiting to be executed would be the last one. Execution order, how we can't guarantee it. The priority is only a preference. And then if there's only daemon threads left to execute, the JVM will finish. Okay, so actually the answers there, yeah, most people said C. 1 person said D, I think. So, or 2 people said D. So a couple of people got it right. Well done. Okay. So let's look at the next one. So equals and hash code, very important methods whenever you are creating your own classes, and particularly whenever you want to put your objects into any kind of collection. So I'll ask you to look at the bottom here. We have a static class, Griffin, and in that class, we basically have a constructor in order to set the name of the Griffin. So this, anyone familiar with Family Guy, you'll probably see this code will look familiar. So in the Griffin class, we override the equals method, and we're basically comparing the name of one Griffin to another. We also override the hash code method, and in there we construct a hash code, an integer, based on the length of the name of the Griffin. So then if we go up to the main method, we can see we have a map. of griffins and strings. So the key would be a griffin object, the value would be a string. And we create 5 griffins there: Chris, Lois, Peter, Brian, and Stewie. And we just put them into the map one after the other. And then finally, we call the for each method on the map interface. And basically, we just output the value of each of the map entries to the console. So we want to know what will be the output to the console. Here's your options. So A, is it 1, 2, 3, 4, 5? B, indeterminate. We can't tell which order they'll come out in the console. C, would it be 4, 2, 5? Or D, 5, 4, 3, 2, 1? It's the opposite. So I'll give you a second to have a look at that code and see if you can make sense of it. Okay, we have one answer already. It's good.
So we have 5 griffin here, and our equals methods compare with length.
It's comparing the length
is
of
not
the name.
Yeah. So we have Chris, Louis, Peter, Brian, and Chris. The length of Brian and Chris the same, right? Also Peter. Okay, I have my answers ready. Let's see. Am I right or not?
Okay, we have we have 3 answers now. Somebody just changed their answer. Fine. We'll give it another few seconds. Okay, 4 answers now. So well, maybe just I'll show the answer then, and if anyone else wants to answer, go ahead. So the answer is actually C. And the values that would be in the map would be Brian, Lois, and Stewie. Okay, so there's a few concepts here which are interesting. First of all, looking at the equals and the hash code method and how they actually are important when it comes to using the hash map collection. The fact, actually, I don't know if you noticed that we're actually using a linked hash map here as the implementation. And then the final thing we'll look at is the for each method on the map interface, which is actually the by consumer functional interface introduced in Java 8. So first of all, at the bottom, we'll look at whenever we're using a hash map or any kind of hash set or hash map collection, the hash code will be used to, first of all, to determine uniqueness of the object going in. In this case, our hash code method there's a bit of a bug in it, because really it will always return the same value, and that will be 0. And so the first entry that gets put into the linked hash map, actually the hash code method will be called and it will return 0, and that's fine. So that's unique because there's no other entries in the map. So then when we come around to Lois, the hash code method will be called again by the linked hash map implementation, but because it's the same value, it will then actually revert to the equals method. So from now on, the equals method will be used to check for uniqueness of the objects. And if you look here, Lois has a different length than Chris, so that's fine. She'll go in, no problem. But then when we come to Peter, what happens is with the linked hash map, what it does, it will find the keys are equal, but it will insert Peter then instead of Chris. So it will just replace. And then the same will happen whenever we come to add Brian, and Brian will actually replace Peter. And then Stewie has a different length, so then he's unique and he'll go into the map as well. Now, you might notice that the order of the entries is 4, 2, 5, and the reason is the insertion, whenever you use a linked hash map, reinsertion of the same key doesn't affect the insertion order. So because Chris was put in first, his key will still be first, whenever you iterate through the entries in the map, and that linked hash map gives us, it will guarantee the order of the keys in the map, whereas if you simply used a hash map, everyone might know that when you iterate over a hash map, you really can't guarantee the order of the entries. So that's why it's a good reason to use a linked hash map. So and an alternative could be is using a tree map to get the same logic here, but it would be way more expensive from a performance perspective, and also the amount of memory that would be put onto the JVM heap. So finally then, if we look at the for each method, as I said, it's which comes in Java 8. So the for each method is really useful, and I think it's applied to nearly all of the collections. And there is a default method on the map interface, but the implementation we're looking at here is actually from the linked hash map. So each implementation of the interface has its own implementation of for each. So just to summarize then, we looked at equals and hash code and how it affects how it has an effect when we use the hash map collection. What benefits we get from using linked hash map, so we can always guarantee the order of when we iterate over the entries, and also how reinserting a key, the order is maintained. And then finally, the for each method on the map interface. So I don't know if there's any Family Guy fans here, would there be? We don't have a poll for that, but
I was right, in fact.
Sorry? Oh, you got it right?
Yes.
Okay, so actually, yeah, we got two people got it right, and 3 people got it. They were close. So if there's any Family Guy fans, you might notice that I didn't include someone's name there, and that would be Meg, because everybody knows that nobody likes Meg, so that's why she wasn't included. Okay, so somebody just asked about generics, so I think we will be talking a little bit about generics. So the next challenge we're going to look at then is sorting and comparing. So again, whenever you're creating your own classes and you want to put them into a collection, if we look at the Simpson class here, so Simpson implements the comparable interface, and it's actually using the generics. So the comparable interface uses the generics framework to allow you to put your class into a collection. We can see here the Simpson as a simple constructor just to give the name. So the compare to method is implemented here, and it returns an int, and it basically compares the name of one Simpson to the other. The toString method is overridden, so we can just get a friendly name for each Simpson object when we print it to the console. And we have the equals method is overridden as well, and it's basically comparing the name of one Simpson to the other. So if we can look at the main method, you'll notice that we have a set of Simpsons, and then we just keep adding new Simpsons to the set there: Homer, Marge, Lisa, Bart, and Maggie. So we have all the Simpsons in that set now. And then what we do is we create a list of Simpsons, and we basically give it the set. So we basically take all the Simpsons from the set, put them into the list. We then reverse the list, and then we call the for each method on the list and just print all the Simpsons out to the console. So your options are basically alphabetical order, Bart to Marge, reverse alphabetical order, which is from Marge to Bart, and then C is basically the reverse of the order they were inserted into the set. And then the final option would be D, indeterminate. We can't tell which order they would print out to the console.
I think I have got my answer. But I'm
Okay,
not
so we have
sure
one
if
answer
I'm going
so
to
far.
correct. Let's see. So how many answers you have got so far?
We have 3 answers so far.
Okay, let's wait 1 minute and see.
Yeah. Okay, still no more answer. I'll maybe go ahead and show the answer. So
Yeah,
okay,
let's
so
go.
the answer is A. Oh, no correct answers for that, I'm afraid. Okay, I know this one was a little bit tricky, and there's a few concepts here. So first of all, we're going to look at, we used a tree set in this example. We're going to look at the comparable interface, so using the generics framework. We're going to look at the tree set collection and the equals, what impact the equals method has on that. And then finally, we'll look at the for each method on the array list, which is a little bit different than the previous one on the map because it's the consumer functional interface. Okay, so the tree set basically gives you a natural ordering of the objects which you put into it. And here we're putting in instances of Simpson, and you can see the Simpson class implements the comparable interface. Now, if you try to put objects into a tree set, which doesn't implement comparable, you will get a runtime exception. So it's very important to implement the comparable interface. So if we look there at the compare to method, which is the implementation of the comparable interface, it basically returns an integer, and what this implementation does is it compares the incoming Simpson to the one we have. So in essence, what it gives you is reverse alphabetical order. It either returns -1 for less than, 0 for equals, or 1 for greater than. So then if we look at the equals method, okay, I implemented equals to kind of trick you a little bit there. The equals method has no effect whatsoever on the tree set class or the tree set collection. The equals method will never be called. It always calls the compare to method. So that was a little bit of a trick there. One thing is, whenever you implement the comparable interface and you override equals, both implementations of those methods should be consistent. Now you can see here that they are different in that in the compare to method, it compares the Simpson name with the incoming Simpson name with the object we have in our hand, whereas the equals does it the other way around. As long as the equals implementation is the same, you know, they're consistent, that's fine. Otherwise, you'll get strange behavior with the set interface. So next, then we'll look at so after, when we get to line 15, basically we have a list of the reverse alphabetical order, which would be Marge, Maggie, Lisa, Homer, Bart. But then we reverse the list, and that brings us back into the alphabetical order that we see. The answer is actually A. And then finally, we call the for each method on list, which is, again, it's a functional interface introduced in Java 8. And basically, the last time we used a Lambda expression, but the nice thing about Java 8 is what we can do is we can specify a method reference. So it's Lambda expressions, as you said, are shorter than anonymous inner classes. The method references are even shorter again than the Lambda expressions. So they've really taken a big step there and made our lives more easier, so we don't need to write a lot of code. Okay, so just to recap then, we looked at the tree set implementation, the comparable interface, how equals doesn't really have an impact on the tree set collection, although it should be consistent with the compare to method. And then we looked at the consumer functional interface for the array list class. So you might look at this and say, well, what if I have a class, a Simpson class that doesn't implement comparable? What if I want to use that in a tree set you know, you shouldn't extend, or the classes should be open for extension but closed for change. So if you didn't want to extend the Simpson class, what you could actually do is, you can see up at the top, when we instantiate the tree set, we can actually specify a comparator. Again, pre-Java 8, you would usually have an anonymous inner class, but for when you're using Java 8, you can actually specify a Lambda expression, which is the same implementation of our compare to method, but you can see that you don't need to actually change the objects that you're putting into the collection. So that's a really useful way of getting the compare to method. Okay, so now we're going to look at another Java 8 feature of streams. And if you look here, we have a list. Again, we have a Simpson class. This time we have a name and an age. And we have we create a list of Simpsons: Homer, Marge, Bart, and Lisa, and they all have their ages respectively. We then turn the list of Simpsons into a stream of Simpsons on line 17. And then in line 19, we actually strip the ages out of the Simpsons, and we do a bit of filtering there on line 22. So we want to get a stream of ages of Simpsons. On 24, we find out what the minimum age is, and then on line 27, we check to see if there is a value there, and then we execute the Lambda expression there. So the options are A, 31, B, prints to infinity, C, it doesn't print anything at all, or D, no such element exception. So again, if people aren't familiar with Java 8, a lot of the stream and the optional interfaces might not be familiar to you, but I suppose you could give it a guess anyway. We have two answers so far. Okay, I'll maybe wait for one more.
It's
Yeah, if you have any questions, feel free to ask.
yes. I don't think we have any question here in the chat, but let's go ahead. We have one more to go.
Yeah. Okay, and the last one's pretty quick. Okay, so the answer is B, prints to infinity and beyond. And why is that? Okay, so I'll go through this as quick as I can. So again, we're looking at streams of operations: intermediate operations, which in this case is map and filter, and a terminal operation, which in this case is the min function, or the minimum operation. So we're going to look at the optional class and what happens when we call if present, and then also the iterate method on the stream interface, which gives us the infinite stream. So streams are basically a construct that was introduced in Java 8, which they basically don't have any stories, they don't store anything. It's basically when we add the intermediate operations like map and filter, we're basically setting up instructions, if you like an assembly line in a factory. So it's only when we call the terminal operation, which is the min on the Simpson edge stream, that data actually starts flowing through the stream. And what we can see is there that we map the Simpsons objects, which is E, and we get the age out of them. So we're now dealing with integers, and then we filter just out the ages which are greater than or equal to 30. So you can see there that on line 19, the context can be inferred by the JVM, so that it knows that we've moved from a stream of Simpsons to a stream of integers. When we call the min method there on line 20, we're going to use this now, yeah. So when we call the min method on line 25 on the edge stream, it basically is a terminal operation, and it will bring back the minimum edge, which at this stage would be 30 and 35 would be in the stream. So on line 27, we're using an optional. And optionals are basically containers which may or may not contain a null value. So if you've ever written loads of if not equal to null code in the past, you'll be familiar with that, the pain of that there. So the good thing about optionals is that we don't have to do if statements anymore. We can call fluent APIs like if present or get value or else. So the optional interface is definitely one to look up in the Java doc. And so we can see here that if there is a value present in the optional called min, then we invoke this lambda expression and we give the Simpson edge in. And on line 28, we basically call the iterate method on the int string, and it just takes the seed value of 30 and continues to add 1 to it, and it basically never ends. So using the iterate method is a useful way to get an infinite stream. And what happens here is we just keep printing out the age plus 1 over and over again by calling the for each ordered method. So it is an infinite stream, and yeah, if you were going to store the infinite stream, obviously you would want to store it in the cloud. And there is one way to limit the streams, and I'll show you that there in a second. So we can call the limit method on the infinite stream to just limit it to whatever number we want. So just to summarize then, we looked at streams, we looked at the two types of operations on streams, intermediate and terminal, and we looked at the optional data type in Java 8 and how we can call the if present method and basically give it a lambda expression which would conform to the consumer functional interface. And one thing to note there is that the lambda expressions use generics, or the functional interfaces use generics, so the type of is always inferred, and that's the nice thing about streams, that you can always infer the context and what data type you're working with. And so then the iterate method allows you to get access to an infinite stream. So the last challenge then is, last but not least, polymorphism. So probably the most important concept of object-oriented programming. So we have an abstract Simpson class here, which when we ask them to talk, it basically outputs the word Simpson to the console. Homer is a Simpson, and he likes to shout his catchphrase, Spider Pig. And then Bart, we all know Bart's catchphrase, eat my shorts. He always gets in trouble for shouting that. Lisa is a big fan of jazz music, so she always likes to say, I love sax. And then we have a little helper method here called tweet, which basically calls the talk method on each of the Simpsons that gets passed in. And then finally, on line 24, we can see the main method. So this is the most important part of the code. We create a new Homer and we pass it into the tweet method. We create another Simpson, and it's a new Bart, and we pass him into the tweet method. And then we create a Lisa object, and we just simply ask her to talk. So we want to know what's going to be output to the console. And there's your answers there. A, B, C, and D.
This one also quite tricky.
Okay, one answer so far. So we have a question here from Chowdhury Mohammed. He asks if you discuss generics elaborately, it would be good for him. Is there anything else you want to know about generics?
Well, we can definitely have another session with generics. I mean, today is too late. Let's not go ahead today.
Sure. Okay, so we have two answers now. And I think I'll show the answer. So yeah, the answer is C.
Okay, so everyone's got correct.
Yeah, you got it correct. So can everyone see everyone else's answers in the poll? Yeah. So there's no need for me to really show the answers.
I don't think so. Oh, once they I think once they provide the response, then they can see answers.
Okay. Okay. So what we'll look at here is we'll try and wrap this up quickly. Method overriding, method overloading, and virtual method invocation. So the trick here is that we have an abstract class Simpson, and if you look at whenever you're overriding methods, there is a hierarchy of the access modifiers. So the access modifier of the override must be at least the same level, or or lower down the stack. So basically, our abstract class it's actually a default method here, which is package private, and then Homer has got public access, so it is an override. Bart has got a protected access, so it's greater than the default package private, so that works. Lisa, this is where the trick is. Lisa's actually a method overload, not a method override, because the signature is different. She actually takes a string in there, so that's a little trick there as well. Then if we look at let's look at the main method. So we create a Homer and we pass them into the tweet method. The tweet method will always call the talk method of the class at runtime, not compile time. So the thing is here that using virtual method invocation, the JVM will always call the override method. So it doesn't matter if the reference variable is a Simpson or a Homer or a Bart, it will always call the override. So that's the one key thing to look out for there. And then, as I say, with Lisa, she was doing the overload, not the override. So we'll recap then. We looked at method overriding and how overloading is different, and then also how virtual method invocation happens at runtime, and the object reference type is not relevant. Okay. So just to wrap up then, today, thanks for your patience, everyone. I know that was quite a lot of intense code to get your head around, but we looked at generics and strings. We looked at the crazy syntax challenge. We had a look at how we can use lambdas in Java 8, and then the method overloading with the inheritance hierarchy about widening and boxing. We then had a look at multi-threading coded, and we looked at the equals and the hash code when we're using our objects with collections. Then we had a little look at sorting and comparable and how we can implement the comparable interface. Then we had a wee look at infinite streams, and then finally polymorphism. So I hope you enjoyed that.
Well, we have covered a lot of things in.
Yeah.
All right. So thank you, Evans and Rafael, for your time. It's almost 2 hours, and yeah. Finally, let's go ahead and summarize.
Okay. So today we could see some of the most important concepts from Java, and here I'm going to share with you the hashtag Java challenge. You can see hundreds of challenges on Twitter with this hashtag. You can access as well NoBugsProject.com, and you can get for free the book No Bugs, No Stress. And you can access thebject.org to check out what are the next events and which presenter is coming here, and it will be interesting to you to see it. And we will be sharing all the code on Twitter, on my Twitter and Barry Evans' Twitter.
Okay, so guys, what you have to do is now follow the Rafael in Twitter. Then you will be able to see a lot of challenges like this 10, and he's obviously putting a lot of challenge, Java small challenge, and then he explains. So go to his Twitter accounts, follow him, follow the Rafael, follow Barry as well. And Rafael has a good projects called NoBugsProject.com. You can even go to his site and subscribe to get the books. He has a nice ebooks for all the challenges he has presented so far. That's what we need to do to get more tweets, more challenge and explanation as well. So thank you, Rafael and Barry Evans, for your time. It's almost 2 hours. I mean, seriously, you have you have huge passions, I would say. And obviously the audience.
No problem. I hope everyone enjoyed it, and yeah, we'll share the slides and we'll share the GitHub repository as well on Twitter.
Yeah.
Yeah, I'll definitely share the YouTube video once we finished in our group, and I'll tweet also, so it can people can reach these materials again offline, or they can watch later. Hopefully, most people, since it's already midnight, most people will watch it tomorrow offline. So
congratulations for the people that are there yet, because it's very late.
Yeah, that's
yeah, we appreciate your dedication, guys. Thanks very much.
Yeah, so let us know. I enjoyed totally, and I really want to have this sort of session in future again. And I'm sure if you guys will help us sort this sort of events again, and let me know if you have any new ideas and challenges and you want to present.
We are honored about it. It was a great honor to be here with you. Amazing public from Bangladesh. They are really dedicated, and it's amazing.
Yeah, it's late here. Almost we have around 20 people so far. So I think it's midnight and 20 people are watching these sessions, which is good. I mean, they have all.
Yeah.
Yeah. So hopefully other people will watch in offline tomorrow. I mean, I'll share these YouTube links, and they're able to see the contents. So thank you again. And do you have anything else to share?
Yeah, we'd like any feedback.
Something?
Any feedback you have about you know, how we can make the presentation better. Our ears are wide open. Thanks very much.
Yes.
Sure. And thanks again for your time. It's really, I really appreciate it. And from JagBD,
no problem.
We really appreciate your effort.
All right. Good night, Bangladesh.
Okay. So thank you from joining us from the Dublin. I don't know how much distance we are between Bangladesh and Dublin, but it must be a long distance.
Yeah.
Okay, thank you. So we are going. We are stopping the broadcast now.
Okay. Thank you, Basler. Thank you. Thank you, everyone. It was great to be here.
So you're welcome.
All right. Good luck. Good night, folks.